got a big thing tonight or something?
No.
That wasn't sarcastic.
I may try something better for this one.
And you're really tired.
I said Seinfeld. Like that was like, I did the right thing, but just.
One question, 20 points.
Lincoln, still sick, I guess. 2-3. Diego, Sebastian will be gone. Owen, school business. Jack. Okay, it's time to get started here. Our bells are turned off. I'm guessing that they're still doing makeup ACT testing. But if you forgot to turn in 107 as part of your homework, I would like the hard copy of that for last chance for full points. And I need you to clear off your desk for the use of mini quiz.
Yes.
No calculators. 2 questions.
Thank you.
I'm putting it on your desk face down, so once you have your stuff turned out, you can flip it over. Okay. I think everybody should have it now. So again, not a big one, 2 points. Not gonna add up or change your grade significantly, but as always, these are gonna add up over time. So I realize these are a little bit slower than the first one, so I'll give you a few minutes before we need to move on. But like we did last time, if you would just turn yours face down when you're finished, and then I'll know you're finished and I'll come get it out of your way for you so you don't have to keep getting up and down. course, I can't give you unlimited time, but don't rush. Make sure that you're not forgetting anything, since these are just 1 point each. If you forgot something, that would be enough to make you miss the point, so. But that's as much of a hint as I can give you. Also, as we go through these mini quizzes, I'm not taking things completely at random. I'm trying to pick out stuff that is a little bit more important. So, as you do these and you wish you had studied more or reviewed more or practiced more, I mean, it doesn't help with today's quiz, but it is stuff that is important for the AP exam, so. Bless you. Those of you that are finishing a little bit quicker than others, you might see that I'm going to give you more time on your circuit from last class at the end of class. So you could get that out and maybe get another question done while you wait, depending on how much longer everybody needs. Guess that's it. So there's a couple of things on that one that I think are going to be commonly forgotten things, but you'll see if you did those when I get those back to you. I'll always try to pass them back to you the next class. You might want to remind me occasionally. The only reason I don't want to grade them and give them right back to you is I want to use the same forms with my B-Day class. So I have a separate form for students that need to make it up. So it's not that, but I need to keep it at least until, actually I can't give it to you on Monday. It'd be Wednesday of next week because my B-Day class needs to do it on Tuesday. Okay, so we've got, obviously we have a few small things. There's probably like 4 or 5 small things I need to show you and tell you about for the AP exam. But there is one more big topic, a topic that takes, a normal class time. And so unless I'm just forgetting something, I think this is the last of the big new topics that we have to worry about today. So I've kind of got this one split up where, I'll tell you some of the stuff you need to know, how to approach the question, do a few examples with you, and then I think there's like 6 or 7 I'll ask you to do today. But this is one that needs more practice as well, so I'll give you more practice on this on Monday. But for now, we need to start off with something. Okay, so before I even tell you what we are trying to do in this one, there are some geometry formula that College Board expects you to know for this section. Now, it's only 2, 3, 4, 5 things, but, well, 4 to 5 things. You could probably say 4. But the with the exception of one, these are going to look different than what you remember doing in algebra. This is a different way to do it. So for question 1A, sometimes we're going to work with squares. In fact, this is going to be the most common one. And what would you say the formula is for area of a square?
Base times height.
Okay, you could do base times height. Base times height. But we need to write everything just in terms of its base. So instead of base times height, does everybody agree we could just say base squared? Because they got to be the same anyway, right? Unfortunately, that's the only one that is pretty intuitive. I'm going to show you where the other ones come from, but at the end of it, you do need to memorize all of these. Semicircle, this is the one that you really, in fact, I don't even really use this formula, but I'll show you what it is and where it comes from, because I guess you can take a little bit of a shortcut if you do memorize it. So here's a semicircle. What would you tell me the area of a semicircle formula to be? You guys tell me louder.
1/2 times pi r squared.
1/2 of a circle, so 1/2 pi r squared. But this is going to be on the bottom, so this is going to be the base. So again, we're going to try to write all of these in terms of the base, and this is what you did not do in geometry. That makes it a little bit different feeling. So what is r, or what is b in terms of r? What can I replace r with?
1/2
Okay, 1/2 b. And then if I squared this, this would be b squared over 4. So the formula that you, again, I don't memorize this one, but it would be a little bit easier if you did. It would be 1/8 pi times b squared. That's the formula for area of a semicircle in terms of this base. Now again, this is the one that you can get around. I don't memorize this, and I'll show you why, but it might be easier for some of you. All right, the next two are about isosceles triangles. So this one, remember, isosceles triangle is where you have two sides the same, two or more sides technically, where the base is a leg of the triangle. So here's an isosceles right triangle, like it says. I'm going to call this down here the base. So all triangles are 1/2 base times height. I'm going to call this b. I'm going to leave it the base, it's on the bottom. But what is h in terms of b? How does h and b compare to each other? They're what? They're equal. So in terms of his base, you could say if it's an isosceles right isosceles triangle where the base is one of the legs, it would be 1/2 base squared. Since the base and the height are the same, we don't need two variables. We really just need to know the other one. Okay, an isosceles right triangle where the hypotenuse is the base. So this time the hypotenuse is down here, still a right one. So it's still a triangle, so we can still start off. Again, you don't have to be able to derive these, by the way. You can just memorize them straight up. I'm just kind of showing you where they come from for some context. But if I call this the base, because it's on the bottom, I will leave it b. Where in my picture, though, would be the height? Where is h in my picture? I haven't drawn it in yet. Right here? Okay, so here's the height, and we need to get that in terms of the base. Well, do you guys see that this would have to be a right angle down here? Okay. Do you know how big this angle would be?
30.
Not 30.
40.
Good. If this side and this side are equal, then this angle and this angle have to be equal. If 90 of your 180s here, that leaves 90 for these two. So each of these are 45. Well, if you look at this right triangle alone, you could do a tangent equation. Tangent is opposite over adjacent. How big is this? Good, it's half of a base. So we can multiply that over. H is half of a base times the tangent of 45. But what's the tangent of 45? It's just 1. So height ends up being b over 2. So if it's an isosceles triangle, we would use 1/4 base squared. Again, you don't have to ever derive these for anybody. I'm just showing you that this is why it is what it is. So there is 2 questions that don't specify in a minute which type of right isosceles triangle we're going to use, but it does make a difference. If the base, if the hypotenuse is the base, we use this. If the leg is one of the bases, we use this. They're slightly different. All right, and then finally, equilateral triangle. Let me try to get some more space here so I can show you where that comes from. Okay, so equilateral. Equilateral triangle. Okay, that's the one where all 3 sides are the same. So since it's a triangle, we know we could start off with 1/2 base times height. Now we're not going to be using that with the calculus because again, we want it just in terms of the base. We don't want it in terms of the base and the height. So I'm going to call this the base, B. Typically we just say the thing on the bottom is the base, but you could always rotate a shape and call it something different. The height would be right here, the distance from one of the vertices to the other side perpendicular. So here's where the H is going to come from. Now, within this triangle, how big does this angle have to be? Good. If all 3 sides are equal, then all 3 angles have to be equal. So if I focus just on this right triangle on the left, kind of like I did over here, I would like to know the opposite of 60 when I know the adjacent of 60. The adjacent would be half of the base. So once again, we can do a tangent equation. Tangent is opposite over adjacent. So the height is half the base times the tangent of 60. And unless you still have tangent values memorized from the unit circle, which most students tend to do in pre-cal by the end of it, you have to do sine divided by cosine. Think about the sine of 60 divided by the cosine of 60. Do that fraction work. This comes out to be the square root of 3. So instead of saying the height is h, we can say the height is square root of 3 over 2b. So the formula we're going to use is square root of 4 over b squared. Now this is one you may have actually seen. I don't know, it depends on your geometry teacher, but a lot of times if you look on a geometry formula sheet, the area of an equilateral triangle is written on there because you only need to know one side length if you have this formula. Okay, so I don't want to dwell on the deriving part too much, but at the end of the day, these are the ones you need to be familiar with that we'll be using today. It's fine to just keep referring to these for now, but before your next test, you need to memorize these. Square is base squared. Semicircle, if you want to memorize it, is 1/8 pi base squared. Isosceles triangle, if the leg is the base, 1/2 base squared. Isosceles right triangle, where the hypotenuse is the base, 1/4 base squared. And if it's an equilateral triangle, It's square root of 3 over 4 base squared. Now, if you want to practice those deriving, then I would certainly encourage that, but you don't have to be able to do that. Okay, so what we're going to be doing is we're looking at one more application of integration. So the first time we looked at integration, it was to add up an infinite number of infinitely thin rectangles to find area under a curve. We did a couple other things, but then the next big one that we did was the most recent topic, where if we add up an infinite number of circles, we can do the disk method or the washer method to find the volume of some three-dimensional shapes. Well, this is also to find volume, so same thing. We're trying to find the volume of three-dimensional shapes one more time, but instead of adding up an infinite number of circles, we're going to be adding up an infinite number of squares, semicircles, isosceles right triangles where the leg is the base, isosceles right triangles where the hypotenuse is the base, and equilateral triangles. And while that might sound hard, the calculus part is actually pretty straightforward. Now, I tried to squeeze this in so that you didn't get like 4 pages on here, but I know this didn't print off well, but this is very important. So please clarify this a little bit with your own writing. So, consistent with what we've done, if you want to know the volume, if it's perpendicular to the x-axis, it's going to be dx, and these are going to be x values. And if you do perpendicular to the y-axis, these are going to be y values. Also, if it's perpendicular to the x-axis, it's dx. This stuff should be in terms of x. If it's perpendicular to the y-axis, it's dy, and this stuff should be in terms of y, not in terms of x. That was consistent with our volume of rotations, so that part should be okay. But it turns out if you want to add up an infinite number of two-dimensional shapes, all you really have to do is integrate the area. This capital A is just the area formula. The same area formulas that I just showed you, the 5 that we just talked about. So if I integrated base squared, because I had an infinite number of squares, these squares are going to be turned up. So the squares are sticking straight up into the air, which is why it's a three-dimensional shape. But if we integrate that, that's how we add up an infinite number of infinitely thin squares. And you add up all of those areas, you end up with a three-dimensional shape, which gives you volume. So let me show you. We're just going to practice the setting them up here. On the back page, you've got 6 or 7 questions. I'd like you to set up and throw your answer in the calculator to make sure that it's correct. But, so I've got a picture here. I've got a function here. Y is equal to 4 square root of sine x. We're not going to integrate these yet, so you don't need a calculator yet. But if I wanted to make a three-dimensional shape, and I'm going to take cross sections perpendicular to the x-axis. This is very hard to draw, so first off I'm just going to do squares. And this conceptually, you're going to be confused conceptually if you can't make this connection. I'm going to do my best. But I'm going to take a point, draw it perpendicular to the x-axis. This is still the flat piece of paper, but then my square is going to come up. It's coming up visually. There's where one square is. And then maybe here's where a second square is. But I'm going to squeeze, and again, these are going up in the air. That's why it's three-dimensional. So if I squeeze in squares all the way through this, I can figure out the volume of this, that three-dimensional shape it would do, simply by integrating since this is perpendicular to the x-axis, I want dx and I want x values for the limits of integration. So this one's a tiny bit off, but just for simplicity, we're going to say it's 0 to 3. And if the cross sections were squares, what's the formula for squares that we should be using? Okay, so b squared okay, so then we just need to think about, well, what is b? What is the base? So again, kind of like the volume ones, it kind of helps if you draw in a couple of squares like I had. Here's the base and here's the base. The base is not always the same size, but the base is always equal to what? Right, or y. This distance we usually call y, this distance we usually call y, but we know what y is. So the base of each of these squares is 4 square root of sine x. 4 square root of sine x. So by integrating this, it's like I'm adding up an infinite number of squares, base squared, where this is the base size, from 0 to 3. That would give me the volume of the three-dimensional shape that we create. If I can find it, I know there is a website that does a good job of showing those three-dimensional shapes. So I will try to look for that when you guys are working. But okay, so semicircle, since it's perpendicular to the x-axis, I still want dx. I still want this stuff to be in terms of x, and I still want these to be x values. So again, we're just going to say it says 0 to 3. Now, you've got two options here. You could either say, I'm going to memorize the semicircle formula, which is 1/8 pi, wasn't it base squared? Okay. And so if I try to draw in a couple of these semicircles, there's a semicircle, here's a semicircle, here's a semicircle. Again, these are coming up off the paper. That's why it's a three-dimensional shape. So what is each of these base lengths? They're y. From here to here is y, here to here is y, and here to here is y. So the base would be 4 square root of sine x. 4 square root of sine x. And that's fine. You can do that. The reason why I don't memorize that formula, and I can still get the same thing, I'll just show you, because this is how I'm going to do it from here on out. I would just say, well, 0 to 3 dx, I know that. I know semicircles are 1/2 pi r squared. I'm not memorizing anything new this way. And then when I set these up, this would be r, and this would be r, and this would be r. So what do all these r's have in common as far as their length? It's half of y. So if you know y is 4 square root of sine x, I would say r is 2 wait, what am I thinking? The radius would be 2 square root of sine x. You guys okay with that? It looks okay to me, but it just depends. If you want to memorize the formula, you just need to get the base. If you want to think of it as 1/2 pi r squared, you're going to need to use your picture to think about what r would be. R and b, or r is always going to be half of whatever b would be. But this is how I would do it because I don't have to memorize anything new. So that's why I do 1/2 pi r squared. Okay, for the right isosceles triangle, again, there should be 2 of these, but this one we're going to say where the base is a leg. Since it didn't specify, we'll just pick. So for that type of problem is good. Well, we're still doing integrating dx 0 to 3. This still needs to be in terms of x. But when it's a right isosceles triangle and the base is a leg, that formula is 1/2 base squared. You don't know that area, you're just integrating area, so you have to know those area formulas. So then if you want to draw a couple of those in, here's the base, it's a leg, and then visually it's coming up in the air, and maybe here's the second one, isosceles, right, this part's coming up straight in the air, but now I can see here's the base and here's the base, and the base is always equal to what? The base is always y, or 4 square root of sine x. I don't want to just say y here because this says dx. Since this says dx, this stuff needs to be in terms of x. So that would give me the volume of the three-dimensional shape if I just stacked as many of these triangles that I could fit together. Okay, so now you're starting to see some of the repetition here. Perpendicular to the x-axis, dx, 0 to 3. You're integrating the area of the shape. Equilateral triangles was square root of 3 over 4 base squared. And then kind of like with the volumes of rotations, you had to be careful about the radius, and these questions you need to be careful about the base. So you might sketch in, here's one equilateral right triangle, maybe here's a second one, but these legs are the ones that are on the piece of paper. This part sticking up in the air. So these are the bases, and I can see this distance from the x-axis to the function we call y, this distance from the x-axis to the function we call y. So the base is y, but I need it in terms of x, so don't say y, say what y is equal to. 4 square root of sine x. So square root of 3 over 4, integrate 0 to 3, 4 square root of sine x squared dx would give you that. So I know this is one that students usually feel a little uncomfortable with at first, but again, we're just integrating the area. We're just trying to plug in the area formula and try to put the base into that. So with this next little group, I'm going to give you a chance to try each of these for a moment before I tell you what it is. So go ahead and different equation, just try to do the square one. Just try to set up the integration and see how close you can get. Okay, I'm cutting you off here. So since it was perpendicular to the x-axis, you should have spent no time knowing that it's supposed to be dx. And then what limits did you use? You said -2 to 2? Okay, that's correct. Those are the x values we're interested in. Okay, what was the formula for area of a square in terms of the base? So base squared. Integrating area is giving us volume. So then the last thing is you had to slow down and think about, well, what was the base? So here could be 1 square, and then it comes up, and then here could be another one, and here's where it comes up. Here is the length of the base. How can we describe that in terms of x and y? Okay, we will need to solve for y. What is this length right here? Just this piece of it. From the, no, I'm just talking about just this part of the base. From the x-axis to the function, what do we normally call this? Not a trick question. This is y. So if this distance is y, do you see that this distance is also y? So your base is not y, your base is 2y. Now, we need it in terms of x, so you actually have to solve this. You need to subtract the x squared over, and then take the square root of both sides. Your base was not the square root of 4 minus x squared, it was double that. And if you're not sketching a triangle in there, or I'm sorry, a square in there, you may not see that the base is 2 of these y's. Distance from the x-axis up is y, distance from the x-axis down is y. There's 2 of them to make up the base. So, you should have been aiming for this for part A. And again, if you missed one thing there, it's probably this too. You probably weren't careful enough about the base. The base is twice as much. Okay, so make a correction there if you need to, and then take just a moment and try to write out the integral that would do the same thing with semicircles. Okay, so I'm not giving you as much time here because you get to reuse some of the same work. So there's 2 good ways to set this up. If you're going to do it the formula way, if you memorize the formula for area of a semicircle in terms of the base, I believe, and again I don't memorize this so I could be wrong here, I believe it is 1/8 pi times base squared. Okay, and the base is still going to be 2y. Now, of course, they're not going to look like squares. They would look like semicircles, like that. But the base is still going to be 2y. So this would be acceptable. Or what I would do, so I don't have to memorize this 1/8 pi base squared stuff. Oh, this is still 0 to, not 0. -2 to 2. I would have integrated -2 to 2, and I would just do a semicircle is 1/2 pi r squared, but r is not necessarily the same thing as b. With these drawn, it looks like r is just 1y. So either of those would work. In fact, if you compare these two, you can see why they're the same thing. This 2 squared ends up being 4. Since 4 is just a constant, you could pull it out front, and 4/8 is the same thing as 1/2. So these are saying the same thing. You need to be able to do one of those two. whatever your preference is. Okay, 2 more to try before I will let you work a little bit more at your own pace here. So try part C, but this doesn't specify, so do the right isosceles triangle where the base is a leg. Again, just try to set up the integral, and you're going to get to reuse some of the stuff from before, so I'm not going to give you a ton of time here. Okay, I'm already going to cut you off because this guy is still from -2 to 2 dx, just like all of them. The only difference is a right isosceles triangle that has a base as a leg has a different formula. It is 1/2 base squared. You can draw in the pictures if you want to. So there's a leg, here's a leg, here's the right angle, and this is the stuff that would be sticking up. But even just one of these lets you see that the base was 2y, and you should have already thought about what y is. So 2 square root of 4 minus x squared. All we're really changing from each of these different shapes is a different area formula. Alright, make corrections there if you need to, and then try one more for me, and then I'll give you directions about the next 6 or 7. You can work more at your own pace. While you start that, I will grade your homeworks and your mini quizzes, and then I'll come around and help you practice those. Okay, so it's still perpendicular to the x-axis, so dx, still x values. The only difference is the cross sections are now equilateral triangles, which have a different area formula. It's square root of 3 over 4 base squared. The base is still the same as what it's been on all 4 of these parts. So if you can find the base for squares, you can find the base for this one as well. That would add up an infinite number of equilateral triangles from -2 to 2, where each one has this as a base. Adding up that infinite number of equilateral triangles would give you a 3-dimensional shape, and this represents its volume. So, one part of this I know that's uncomfortable is those formulas. Most of those formulas are written in a way that you haven't learned, so at some point you need to know those, but for today you can flip back and forth. I feel like the structure of each of these is pretty similar, so it does get easier. So that's why I kind of split it up over 2 days. But I need you to practice some of this to see how you would do. So I think now on the back page, is that where it goes? There's like 7 questions. You need to pay attention to which one is perpendicular to. You definitely need to pay attention to the shape, because that's going to determine the formula that you use. It's either going to give you the bounds, or you might have to find the bounds. But you need to set up the integration that would give that. I need to see that on your paper. Then feel free to just throw the integral in your calculator and make sure that you get this as an answer. I gave you the answer out to the side of each of those. So when you do question 1, when you type that in your calculator, it's going to give you a decimal. But if your decimal is the same as the decimal for pi over 2, then you know you did it correctly. And then you can move on to question 2. Alright, so if you would, go ahead and try those and see how those go. And then if you get real stuck on one, you guys are welcome to work with your neighbor on that. And I will come around and help in just a minute too. So take as long as you need to do those 6 or 7 problems, and then you can have the rest of class to work on that circuit from last time. And if you don't finish up that circuit from last class, then that will end up being what your homework is.
Oh shoot, I didn't see it.
Again, I'll come around in just a few minutes to help you with whichever ones you're getting stuck on, but don't stay stuck on one. Move on to another one if you need to.
Number cell settings for all the first one.
Not here, not here. Just a second. There we go. I lost it. Yep.
Number 6. I'm not sure I'm doing wrong, so I tried the formula with the two and when I did this, it's size of
Well, I definitely think your balance would be off.
What?
These bounds might make sense if you're caring about X values. But since it's around a Y, it needs to be Y values.
Okay, I see.
3600.
cross section by a plane normal. X-axis. That seems to say perpendicular. Normal means perpendicular. Okay.
What does that mean?
They used to make you know that for the AP test, but they don't ask that anymore, so.
It's a circle. So it's like when on each side, so you have to multiply place those two.
You're right. Well, it's squared.
Listen, guys. Just the smallest piece of I'm just supposed to draw that. I just don't know.
Oh, no, minus.
For, oh.
I'm sorry. I thought I picked it up.
Okay, I'm gonna start coming around and let me know which one.
Is there stuck on any yet? No? Oh, yeah, this is the bad.
That's a good one, Samuel. It's a good one. You're really funny.
We're all stuck. Yeah, go on.
I feel like that's kind of offensive. Like, I feel like that's kind of I call
Oh,
it
yeah.
Because it's a species. It's like calling someone a dog.
Absolutely.
We're not racist, but I think it's like calling someone like a moose.
I call somebody.
Or calling someone like a moose. Like it's not. Yeah, whatever it is. I won't get canceled. That's good.
3 to 3, yeah.
Okay, yeah, that was a bad example. It'll be plus minus 4.
This would be a circle, center is 0, x minus 0, y minus 0. The radius of. Okay, and you're doing equilateral triangle. circle that.
So we put it in.
So we can try.
But the way you wrote this, your calculator thinks you only want to square the square root. You need to square the whole root. Or you could just change the 2 to 4. If you want to square the whole root. Either one. And that should be an unusual decimal, but 36 is the yeah, that's where, like, if you're trying to do it without a picture, like, I know you don't know the equation of circles super well. If you try to do it without a picture, you don't know if the base is gonna be y or 2y or. Right.
Let's get 36
No? Okay.
36.9.
Well, I see one thing here. -4 to 4, but you're doing it perpendicular to the y-axis, so it should be. No. This isn't a full circle. This is just half of a circle.
Oh, wait.
It's only the top half. It would never be negative. So, just it's based on y values, doesn't change the balance, and that might be enough of a fix. Okay, y'all have one that's been harder than the others? It's one you have. Okay, is there something I can help with? Number 6. Actually, your 6 might be different.
It's the first one.
Oh, yeah. Because.
So what does that look like?
No, I got that.
You might have gotten lucky. This shouldn't be -4 to 4. -4 to 4 would be the x values, but you need the y values because you're doing it perpendicular to the y-axis.
It's supposed to just plug it in.
Well, the quickest way is if you guys would know what that graph looks like.
When does the
Oh, is this like?
when does the square root of something give you something negative?
Does.
Doesn't.
So,
Y values are 0 to 4. X values, if you were doing it perpendicular to the x-axis, it would be -4 to 4, but since it's perpendicular to the y-axis, it's going to be 0 to 4. You got one I can help with?
Yeah, you said like, but I'm not sure.
Sorry.
For normal, it's just the same.
Normal means perpendicular.
So it's just.
Yeah, it just means perpendicular. Yeah. In fact, they used to give you AP questions where they would ask you about normal lines, but they don't ask that anymore, so we don't require you to know. But that is a pretty common math term. Normal means perpendicular.
For. Yeah, D3.
Thanks for your lesson.
Okay, I'm going to now grade the homeworks for a couple minutes, get those put in the grade book. I know some of you are closer to finishing this 116. I would say before you put it up, well, obviously if you have some questions, leave it out so I can help in a few minutes. But before you put it up, you should probably circle or write yourself some notes about the things you didn't think of. And on Monday, I will let you practice this skill a little bit more to get a little bit more comfortable with it. But as you finish this, though, the rest of class is giving you more time to do that circuit from last class. So the sooner you move on to that, the less homework you're going to have. So.
never mind, that doesn't.
Oh, two items.
Just move on. Just move on. Sit.
Because of it's in the, it's going this way. It's going this way, not this way. So that's
Where do you add the tea bag? Here. Well, I put it inside of parentheses and it was great.
Yeah. Just put it into 60 minus X all of that.
Ah. That's the fingers. So do it in terms of line. So I can use T as. So you do T as. Yeah. What do you want? I want five.
Hold on, his hand was up first. Since it's perpendicular to the y-axis, you need to be using y values. That wouldn't be -4 to 4. I drew the picture out there.
It isn't negative 44?
Well, it's to the perpendicular to the y-axis, so you should be using y values. This doesn't exist down here. There's no square root of anything that gives you negative values.
That's fine.
Mine are out of order. Is -y squared plus 16.
Yeah.
It's good to me.
Like 4 is 2, so it's 4.
Are you serious? I figured it.
Well, where's your square root of 3/4?
Oh, what's that up?
this side here is square root of 3 over 4, and do a square root of here.
Nothing.
Why times 3 then?
So this is
No, I'm saying right here. Where you wrote this, I think it's correct. This is not what we're typing in calculating. You typed in this part. So you need to take that number, whatever it's given, you multiply by the square root of 3 over 4. You're multiplying by 3 over 4. Oh, I see what you're saying. Okay, I just did complete decimal. So yeah, if you don't want to multiply in the square root of 3, okay, then you should be multiplying by 3. Oh, okay, yeah. Yeah, so it ends up being the same. It's correct. But I'm not sure if you know it's correct, because what I would say is, well, if this was an SRQ question, they're gonna make this where this is manual food, like, they're gonna expect you to generate like a point or two for setting it up, and maybe a point two. If it's a calculator question, just multiple choice. Just throw the
Or is it
whole
not
thing in the
hard enough?
calculator, get a decimal, and in worst case, compare the decimal volume. Yeah, I mean, you're adding a couple extra variables by the way. Not doing the sort of 3 part, you know, that's supposed to be part of your answer, and then multiplying by 3, so that's not part of your answer. I would just throw the whole thing in, get a decimal. Was yours the same issue as hers? Is this it? Yeah, that's not what you have.
Oh wait, this is not.
This is the base square, right? Yeah, you wrote it, you said the calculator, you wanted to make sure it's square root. You're not also doing it, you do. That's right. Gives you another word of operation, it is thrown in first, so then it comes into the multiplication. So you need to be parentheses, but then you know what 2 squared is, you can just change that to a 4.
Oh, that's how you don't.
But you just, that's the second half problem.
No, I didn't. You didn't? You got 8 over 3? Did I? Oh, to the rest of your
I got that, except I would say that the base is gonna work here.
I put a 1/2 of the square.
Well, because
I do that.
this, from here to here is x, right? And here to here is x, so the whole base is 2x's. So when you solve that for x, you need to double it.
So 16.
The whole matter was the that was yeah, it was like the same one. What was this?
Okay, I agree, yeah. So that puts that over 4 too. Now it's close. The other thing is, you didn't use the right. This is an isosceles right triangle, and the hypotenuse is the base. If the hypotenuse is the base, it's this guy instead of that guy. So it should be 1/4 base squared, not 1/2 squared. It's a different cross section. So if you change it to 1, it's just a different area formula because the base is hypotenuse.
I meant like a yes. Like a top.
Did I answer, did you figure out that one?
Yes, it was the one that you just. Yes. Like a soccer ball. No, in a good way. Yeah, I feel like you have all these songs in the back.
For James and John, but
Okay.
semicircle, maybe just look at a circle.
Equilateral triangles.
Yeah.
Or did you? Equilateral triangles perpendicular to the y-axis. This is the up part. How big is this base?
Two, it would be 2x, right?
Correct.
2x.
And so if this is what y equals,
Raise the power, so 3.
solve this for x and then double it. That's, yeah.
This looks good, but it's half of, wait, what number was it?
Yeah, I know.
I think your base was close, but it should be twice as much of what you had. So solve this for x, and your base is not x, it's 2x. Double it, and then I think it'll work out.
Dang! Oh my gosh, I was just like, it's stressful.
Like,
Yeah.
Which was it? How do you write it?
It's
Well,
weird.
so if I draw in, that's what I was trying to draw up there. You see where they gotta be perpendicular to the y-axis. So the base is actually 2x. That whole distance.
Oh, you completely fine on skating, you're already in skating.
From the y-axis to the right, this length would be x.
Doesn't matter.
So the base is double, it's 2x.
I just.
So you need to solve this for x, and then double it for your base.
Oh, so is the x always gonna be from like the axis to where it goes?
Yes. X is always from the y-axis, how much you go left or right.
Okay,
Y is always from the x-axis, how much you go up or down.
I see. Here.
I tried that. Still, it's like half of what I need.
It's, the way you're typing this in. This is supposed to be base squared, but the way you have it written, you only are squaring the square root. And your calculator does order of operations, so it does exponents and then multiplication. So you either need parentheses here, but since you know 2 squared is actually 4, you could just change that to a 4 and then it'll work out. So
You gotta make sure that you're actually squaring the whole base, and not just part of
So
it.
this is like an equator if there was any.
Yeah, there we go.
Also,
Get
says
done?
y equals 0.
What about the
X can be either.
circle from last class? That's
So
gonna
y
be how
equals
much
0,
time.
x can be either.
You need to
So
make sure that that's done before y'all call quits for today.
I was like, so it's still right. Yes.
Oh, wait, what?
I forgot. I've been forgetting.
Mr. Johnson,
Yes.
can you explain something really quick? So.
It's a math question?
Yeah.
I'm so proud. I want to take years.
Okay, so, at first,
Yeah, I'm sorry, I just had to, you're the first one to ask a question about this, so I have to like shift my brain. We're doing this.
oh, sorry.
Okay, that's what I got too. I just thought.
We squared this first, and 16 minus, or, and then we did
Oh.
x. We raised
Why is this one upside down?
Well, tell them what you did, and then this was.
I mean, that's fine, you can practice integrating by hand, but I also said just let you practice it.
I did, but I'm not like this.
But on that one, first off, I'm not
This
sure.
one, this one's the.
Number 8. But I think it should, well, I might be wrong about that. It's your second reading here. You're rotating it around this line. Okay, so if you think this is little r, let's use a couple of values. If x was 0, how big was little r supposed to be?
I don't understand.
That's because you don't have a picture. You thought you should be. Right, so when x is 0, this is supposed to be the radius, because it would be doing something for this.
Oh, true.
What you're saying
Oh,
is
this
0.
is right.
Because when x is 0, this is 0. Okay, let's do another one. When x is 2, what should the radius be?
Yeah.
Okay, what is it based on 2 little r?
think it's 18.
Four.
Oh, wait, do we
So
use-
that's not the right OR.
Oh, so we switched.
Oh, it's called, oh, maybe it's on Fiberglass?
You gotta think of a different way to
Wait,
describe
no.
this link.
Oh, yes.
This link,
Oh, you're right, you're right, you're right.
This-
So expensive.
whenever, this radius changes, it's always gonna be this distance or minus however much this is. This is 4, this is a little bit less than 4, this is even less than that. Your small r is 4. There you go, it's 4 minus x squared. Now it's hard to get, but that's why you have to test a couple x values, because
What's your gradient?
it's not, if you were going from here to here, you wanted to know the distance, then sure, it's x squared. You're going from 4 down to 5. So it's 4 minus square root of x squared.
On the last.
Do teachers have a
Oh,
problem?
cool, where'd you go on the last, like,
Have a problem?
Yeah,
Okay.
like, do they have their own little dances every year? You should bring it up, just bring it away.
what'd you get?
I wanted to go to prom, I could just go to y'all prom, so great.
Yeah, but that'd be weird, like a teacher was like, if I see you in the mosh pit, I'm leaving, I'm going to Andy's.
It's because I studied that a lot, and I bet.
I like prom cooking and like every other dance.
I bet Andy did.
Prom was much more formal.
Is it? Is it
I
actually?
studied.
You don't have to get your
Finish, maybe try. I guessed it. I guessed it. Cause I actually didn't
So
finish.
you, I can't read that straight up.
Oh, hey,
Yours is the,
Your foot is back.
It's been back.
you think the big R is
What?
0?
Excuse me.
I have an 81.
I haven't really.
I am dying. I got a 50 on it.
Just making the cook baby worse.
Oh, geez, Spencer. Do you guys need to have like names? Would we call these ones or would we call these?
No.
I'm not thinking.
I would say, so if you're rotating
call
around
you
this line,
Spencer.
here's the
No,
point,
call
vertically
you
away.
Tony.
So these would be the points you try to create.
Tony.
So those should always be.
The only thing going on
This
is
distance, this R difference would always be 4.
like, the last name.
And then this is the hard part.
Like, that's all.
Your little R is
Is there an
always
animal?
based on what you're saying, the little r is, when x is 0, the small radius should be 0. But when x is 0, the radius is supposed to be 4. Also, when x is 2, you're saying the little r is
You know the,
negative 4, which makes it but when x is 2, r is supposed to be 0. You're touching it, which there's not going to be a cross section. So you're going to come up with a different small r.
you don't know the video?
So to me, what I would say is the
Yeah,
small r is
something.
gonna be 4 minus whatever that function is. 4,
Yeah,
a
you
little bit
want
shorter,
to
4, a little bit shorter. So the small r
Almost
is
like
4
every
minus
mind
x.
population.
Yeah, I'll watch it.
And the only way to really do that
Finds that button in this.
consistently is force yourself to plug in a couple x values. Think about when
Really
x
funny
equals
when
0,
like
see what
having
you're
X
saying
values.
little r is, and if that matches up with your picture,
Scroll
then great.
clicking.
But if it doesn't, then you gotta tweak it a little bit.
This is so- That's-
Mr. Tony?
It'd be 0 to 4.
I was writing this.
You don't know. It'd be 0 to 1. Because I think that right value when they intersect is just 1.
Okay.
If you can't see that from your vision track, that means you see something.
Yeah.
Very.
Let's see, if we come into here, this would be a 4. So we take this into here, it would be 8.
Which one are you on?
0 to 2.
I got a negative.
What, bud? You need to get on that.
And then that's why it goes, oh yeah.
I can read it. It's a little bit. Oh, yeah.
So the issue there is.
Okay, somehow I got 60.
Alright, so that was through two.
Like, would you just
Either your big R or your little R both.
She just looked like that.
This one is when you say.
This.
Sure.
The other one does
Oh, it's still good.
right?
I did that.
Zero.
I didn't.
You're trying to rotate it around Y equals 6.
Just square the first.
Yeah, you're probably doing the same things.
This test is, if X is 0, how big is 6? I'm taking, when X is 0, and I'm rotating around this line, you say the radius is 0? Yeah, it's supposed to be 6. But this can't be the right formula for big R.
It's like, it's big R squared, but it's a little.
We agree that it's five. If you got it to through square, that is two.
So you gotta get creative.
Oh, I forgot to talk about how long I
Is it because of that missing space? I don't understand. Why is it?
Well, you can see that it doesn't. It's
Yeah.
supposed to be 6,
Well, it's on this.
right?
Yeah.
But by your formula, it's 0. I would say big R is from here to here, from here to here, or here to here. So it's always 6. Subtract wherever this function is. 6. Yeah. Now when you test this works.
Yeah, yeah.
And you can test like X equals 2. What's this Y equals 6?
Yes.
So
I got
X equals 2, then I would be
106.65
saying the
divided
big
by
R is equal to 2. So when X equals 2, now my fingers are straight. This actually goes up to 4, right? So then the big R, the 4, that makes sense. So now I feel better about this.
Okay.
Okay, now if we do something the same for the little r. Okay, so when X is 0, how big would you say the little r is?
What's up? Durham, oh,
Is that right?
You're trying to trick us with these.
No, I'm not. I didn't make it up. Here would be the small one.
Whoever made that was trying to trick us.
So we gotta do the same type of fix for this. This is 0.
What would you do? Would you draw it?
I think it's 5.
Is that right?
If I use 2, it changes them.
So 2 minus 4x minus 2.
How big is it at a max?
4.
From 6 down to here.
What?
This is 6. And then here, what is that?
6.
Yeah.
6 to 0.
Okay, so the small r is at those 6. Then it gets a little bit smaller, a little bit smaller, a little bit smaller.
So 6 minus.
6 minus whatever that was. 6 minus whatever that is.
Oh my gosh.
It's the whole thing. It's the washer.
That is weird. Rude, actually.
We're gonna have to wait for this.
What did they put down on this?
We gotta share it with us.
The work looks good, but I don't know about the highlight.
Yeah.
I thought you had a master.
I did get that.
Okay, I think we're low on time here. Yeah, guys, we're actually down to about 3 minutes, so I'm gonna adjust this just a bit. This 114, I'm gonna ask that you try to do a couple more questions, but I can see we need to spend a little bit more time on it, and that's okay. So try to do 2 or 3 more by Monday, please, but you don't have to have it finished and turned in by Monday like I originally planned. So, and if you've already put the time and effort into it, then that's great. You'll just have it easier later on. So. Okay. Try to figure it out by Monday, and then you can ask me then.
I don't have it either.
People try to every day they're done.